Hi guys, this week we are working on wave speed. This is something you should be a little bit familiar with already just because this was introduced in your choice notes last week. But wave speed is how quickly energy moves through a medium. Medium meaning what substance is it moving through? Is it moving through the air? Is it moving through water? Is it moving through earth like you might have learned about last year with earthquakes? Is it moving through space, through the vacuum, any of those things? So how quickly does energy move through whatever it is it's moving through? So to calculate wave speed, we need to know the wavelength and the frequency. Wavelength is the distance between two identical points on the wave. So it's easy to pick from a crest to a crest. So that distance between crest to crest, that's going to be your wavelength. You could also measure trough to trough. That could be your wavelength. That would be the same distance. Or you could measure from one point here to the identical point here. That would also be your wavelength. Wavelength is from one point to the matching point on the next that matching point. So crest to crest is what I tend to do. That is easy to keep straight for me. You could do trough to trough. You could do whatever as long as it's one point to the next identical point. We're measuring this in meters. If you measure it in something else like centimeters, when you do your FET, that's going to measure, the ruler on there is going to be in centimeters. But remember, you can change centimeters into meters. There's 100 centimeters in 1 meter, so that's easy conversion. The other thing we need to know if we're going to calculate wave speed is frequency. So frequency means how many cycles per second. So if you picture a moving wave, it's how many of those oscillations per second. So frequency, the frequency is how many cycles per second. So 1 per second. However, we are not, you could use the unit 1 per second, but we're going to use a more specific unit for this very specific purpose. So the frequency is how many cycles per second. But the unit we're going to measure it in is hertz. So hertz, 1 hertz, that's the way we abbreviate it, is equal to 1 per second. So how many cycles per second is how many hertz? So 1 cycle per second is 1 hertz. Now there are 3 variables that are involved in these wave speed calculations. The first one is the wave speed itself. So wave speed, look at this. Wave speed is the one variable. It's abbreviated with a lowercase v. Wavelength is the next variable. It is abbreviated with this Greek letter called lambda. Wave speed, the variable for it, is a lambda. Frequency is the third variable. It's abbreviated with a lowercase f. The units that each of these are measured in, wave speed is measured in meters per second. So we abbreviate it like that. We're familiar with that. Because we did in the fall, we calculated speed using meters per second. It's the same thing here. We're just looking at a different way of doing speed. We're not running down the street. Now we're sending waves down. Wavelength is measured in meters. If you need to convert centimeters to meter, there's 100 centimeters in 1 meter. Frequency is measured in hertz. Hertz is abbreviated like that. And remember that 1 hertz is equal to 1 cycle per second. But we're using the unit hertz. So here's the equation triangle for that. We could say velocity is equal to wavelength times frequency. That's what we have written here. Velocity equals wavelength times frequency. If we wanted to solve for something else, let's say we want to solve for wavelength, we would have wavelength equals, velocity's on top, over frequency. So wavelength equals velocity over frequency. Wavelength equals velocity over frequency. What if we wanted to solve for frequency? We would have frequency equals velocity over wavelength. Frequency equals velocity over wavelength. So those are the same equation, just set equal to solve for each different thing. I'll do one or two of these practice problems with you. So this one's already done, but let's pretend it's not. So here's the first one. A wave has a frequency of 5 hertz and a speed of 25 meters per second. What's the wavelength of the wave? So first thing, it's been a long time since we've done practice problems together. First thing we want to do is go through and identify the given in the problem. So let's look and see what's in here. A wave has a frequency of 5 hertz. Okay, here's the first given, 5 hertz. That's a frequency, so you could write frequency equals 5 hertz. And a speed of 25 meters per second. Here's another given, 25 meters per second. That's the speed. So wave speed is 25 meters per second. It's asking what is the wavelength. So wavelength is what we're trying to solve for. So then you're going to come over here, write down the equation you're going to use, set equal to the thing that you want to solve for. So we're trying to solve for wavelength. So we're going to have lambda wavelength equals wave speed over frequency. Then once you have your equation written down the way you want it, then you're going to plug in your given. So wavelength equals your wave speed over, it's hard to see, over your frequency. Do the math on the numbers, and that's what you get. That your, well, I can't fit my hand. That your wavelength equals 5 meters. Okay. Next one. A wave with a frequency of 14 hertz has a wavelength of 3 meters. At what speed will this wave travel? So go through first and identify the given. So a wave with a frequency of 14 hertz. Okay, 14 hertz, that's a frequency. That's our first given. So frequency equals 14 hertz. Has a wavelength of 3 meters. So 3 meters, that's another given. 3 meters is a distance, so that's the wavelength. So wavelength equals 3 meters. At what speed? So we're trying to solve for speed, for wave speed. So that's what I'm trying to solve for. So I'm going to write down my equation. I'm trying to solve for the wave speed. So I'm going to set it equal to that. I look back up here, wave speed is going to be equal to wavelength times frequency. So wave speed equals wavelength times the frequency. Then I plug in my given into that equation that's already set equal to what I want to solve for. So the wave speed equals wavelength is 3 meters times the frequency is 14 hertz. Then do the math on the numbers. So 3 times 14 is going to give me 42 meters per second.